Good afternoon, everyone. Thanks so much for joining us. Even though I can't see you, it's great to know you're here, see your names popping up. Some of them I recognize and some of them I don't. For those of you I don't yet know, my name is Miriam Aylward, and I'm the Executive Director of NESI, broadcasting to you from my home office in Leverett, Massachusetts. NESI's mission is to advance the adoption of sustainable energy practices in the built environment by cultivating a community of practitioners who share, collaborate, and learn. Over the last couple of months, we've been busy finding ways to continue to connect our community remotely. I encourage you to take a look at nesi.org to learn a little bit more about what we're up to. The presentation you're about to hear is entitled Public Handwashing Systems Design Considerations. The webinar is a sponsored breakout presented by NESI member Emacs, and we're very grateful to them for sharing the work that they're doing. Emacs joined the NESI community nearly a year ago during a pro tour of a project in Cambridge, Massachusetts, which you'll hear more about later in the presentation. Since then, they've supported NESI in many ways, most recently by becoming a sponsor of Building Energy Boston. In just a minute, you'll hear from Chris Anderson and Selena Carella from Emacs, and they'll introduce themselves. I just want to say, Chris, Selena, and everyone at the Emacs team, thank you so much for all your support. Before I turn it over to them, I want to run through a couple of tech tips. First, although you don't have the power to speak in this webinar, we do want to hear from you, specifically your questions. So please use the Q&A function at the bottom of your screen to submit questions. We'll be keeping an eye on them throughout the presentation and also setting aside time at the end to discuss. Second tech tip, we recommend that you select fit to window and side by side under view options at the top. That seems to be the best way to guarantee a good viewing experience. So thanks again for joining us. Ask questions, tell us what you think, and enjoy the presentation. With that, I'll turn it over to Chris and Selena.
Hi everyone, my name is Selena Carella and so glad to be here with you today. I'm from Connecticut here, our world headquarters in Waterbury, Connecticut. I am also working from home at this time. I am part of the training team and marketing departments at Emacs and working mostly in content development. And I would like to take a moment to tell you that this continuing education unit was something that we began development on late last summer with a plan to launch it in Q1 of 2020 and had no idea how relevant it would become so quickly in March when we did our first presentation. So with that, I'd like to turn it over to Chris Anderson, who will be presenting today.
Hey, good afternoon, everybody. As the folks prior to me mentioned, my name is Chris Anderson. I'm with Emacs. I'm the Northeast Regional Sales Manager, covering Maine to South Carolina, which is actually a little bit broader than just the Northeast. But I'm pleased to be here. Proud of what we're doing in regards to the partnership. And with that said, we will get into the presentation. It's a relatively long presentation. I'll move along pretty quickly, but I'll try not to be too quick where I'm not thorough. But with that said, just make sure to use the Q&A section because we will be addressing all the questions at the end. So with that said, here we go. Okay, so welcome, Continuing Education Unit presented by Emacs. The course is copyrighted, so no reproduction, distribution, display without our permission. Feel free to reach out to us and I'm sure we can work out the details if you would like to use it. In the course, the importance of effective hand washing and its impact on global health. As Selena mentioned, wasn't meant to be opportunistic, but the timing worked out pretty well and hopefully we'll be able to, teach you something. So when you're developing, buildings and projects, you always got to think about hand washing. And one of the challenges creating a code compliant, reliable system with the right balance between performance and efficiencies from the architect to the engineers all the way down to the contractors and facility managers. So we'll review plumbing codes, health agency guidelines, regulatory statutes, and provide insights into specific water heating technologies and considerations when you're developing that system. There's a lot to learn here. So one of the things we'll talk about are codes. There's a few codes that we'll touch on that you see here. Primarily, we'll touch base on UPC, IPC, and IECC. A lot of the health organizations that you're hearing about, these days, World Health Organization, CDC, we'll tie all this into the presentation and the role that they play into promoting hand washing. How does temperature impact hand washing, both positively and negatively? We'll review that. You'll be able to understand and discuss the differences between traditional and non-traditional water heating technologies and discuss the strengths and limitations of both. And then we will talk more about electric tankless water heating as it plays into hand washing and other types of applications. So we want to talk hand washing. Where did hand washing start from? So this gentleman here, I always destroy his name, so I'll call him Mr. Ignaz. Hungarian obstetrician is kind of, widely credited for starting hand washing. And, he was an obstetrician, so childbirth, and there was two, facilities where that would take place. One was the second clinics, which are your second tier facilities. Primarily, they were midwives. And then you had your first clinic, your premier hospitals and premier facilities. What he noticed is the mortality rate was 3 times higher in the first clinics than it was in the second clinics. So with anything, you put a little, thought and effort into figuring out why. And what he found was the first clinics had a lot of activities going on, primarily autopsies, where there was cross-contamination from one activity to the other. He started implementing some hand washing activities, and lo and behold, the mortality rate fell below 1%. Simple practice to figure out what's going on. Unfortunately, back in that time, there was a lot going on in the world, the Civil War and everything else. So it really took decades before hand washing really took place. But thanks to Mr. Ignaz for starting the trend. Today we hear about hand washing everywhere. 2001, Henry the Hand Foundation developed National Hand Washing Awareness Week. CDC, everywhere and anywhere, always talking about hand washing these days. Global Hand Washing Day. This is pretty cool. The first Global Hand Washing Day, October 15th, 2008, when over 120 million children around the world washed their hands with soap and water across 70 different countries. We're pretty fortunate to be in the environment that we are, so we might take for granted the infrastructures that we have, but being able to get that many children across that many countries, the opportunity to wash their hands effectively is a great cause. So when you're thinking hand washing, what do you got to think of? One of the first things you got to think of is the facility private or public? And while you would think that was such a simple answer, it could be a little bit more complex, but the two definitions are in front of you. But to summarize it, private is a private fixture, non-public toilet room where the fixtures are intended to be utilized by a family or an individual. On the contrary, public, your hotels, airports, restaurants, service stations, where the fixtures are intended to be utilized unrestrictedly. So simple definition, but there could be some complex, some challenges understanding that in the marketplace. So what are the benefits of hand washing? We all know that it halts the spread of infection and is effective in preventing the spread of diseases. These diseases we've been hearing a lot about lately, so I'm not going to, sit there and, rattle them all off. But the most important thing that you can take away from this whole entire presentation is that the adoption of good habits is the most important factor of hand washing. How do you physically wash your hands? The rest of it is providing facilities to promote that habit. And the habit is intended to protect the vulnerable people, the young, the old, the immune compromised, and those with underlying health conditions. Effective public hand washing is dependent upon effective service water heating that is efficient, compliant, accessible, safe, and consistent. Those banners that you see on your right-hand side, they're going to pop up throughout the presentation. Just keep aware, keep note of them, because those are the bullets that we'll be talking about on those slides. So I think we were all taught at a relatively young age that the world is made up of 70% water. Of that 71%, 3% of it is fresh water. Of that 3% of fresh water, the 3% of the fresh water, 65% of it is frozen in the glaciers. Potable water from groundwater is only 0.3%. So it just goes to show that we really got to pay attention to the efficiency of our plumbing systems. To break that down into a little bit more of a comparison, if the water supply in the world was only 26 gallons, the usable water supply would be 1/2 a teaspoon. Really makes it simple to digest. Breaking down the water usage in the US, 58% is industrial, 33% agricultural, and only 9% of it is domestic. 600 gallons per day per person diverted to irrigation and livestock use. So we're thinking about efficiency in plumbing systems and how do we save water. Here's a great example of a scenario to consider. Your average home has 125 feet of 3/4 inch pipe, which, run through the math, it contains about 3 gallons of water. You and your family purge your piping networks 10 times a day to get hot water to the fixture. That's 31 gallons of water down the drain. Over a year, across 25 million homes, that's 300 billion gallons of water sent down the drain, waiting for a comfortable temperature. Easy to think of a couple different ways to conserve water. In the water, you don't even have to think about, not only have to think about the supply of the water, but you got to think about the waste. How does the waste and the drainage and everything come into play? From the U.S. Geological Survey, we all know flow rates of fixtures are regulated, but what's the average consumption based on the usage? So this chart here will give you an overall consumption based on an application. So washing your car could be anywhere between 30 and 40 gallons. Cooking 3 meals a day, 8 gallons. Taking a shower, 40 gallons. So while we know the fixtures are regulated, what's the application? Obviously, that's going to vary, use to use, but it gives an overall synopsis of the overall consumption. Think about your leaks. A leak that fills up a coffee cup in 10 minutes is going to waste 3,000 gallons of water in a year. Fix those leaks in the sinks. A leaky toilet, 22,000 gallons of water wasted every year. Plenty of opportunities to be more efficient. So what does water do to the body? The body's made up of water and bacteria. You got to have the right balance. The human body is 60% water, and water plays, a ton of roles in our body, from digestion to saliva to joint operation, body temperature regulation. It's extremely important to, supply our body with the water. Now, the bacteria, human body contains trillions of microorganisms, outnumbering human cells 10 to 1. The average 200-pound adult will have 2 to 6 pounds of bacteria. Plays a vital role in human health. So how does hand washing play into this? Hand washing is critical to maintain the right balance of water and bacteria and eliminating the harmful bacteria. There's 219 virus species known to affect humans. Coronavirus, Salmonella, E. coli, protozoan. There's 219 virus species out there. We're washing our hands removes them, creating the balance of water and good bacteria. One of the most harmful ones that we might most be aware of is polio. Luckily, the vaccine was developed in 1953, but polio is a viral infection that can cause paralysis or death. Easily spreads from person to person, and the World Health Organization has a goal to completely eradicate it. Poor sanitation areas is where polio spreads the easiest, because it goes from feces to water to food, and people that even don't show symptoms, they can still carry the virus for weeks. So sanitation is extremely important, and hand washing is one of the most important activities to prevent the spread. Hand washing is the best defense for everyone, everywhere, any time of year. Diarrhea, pneumonia, leading cause of children and leading cause of death in children under the age of 5. Hand washing with soap is among the most effective and inexpensive ways to prevent these diseases. Hand washing with soap impacts just not the health and the nutrition, but also education, economics, and equality. So, number one question of the day, what is the ideal temperature for hand washing? Give a couple of seconds here to let this poll roll out, but let us know your thoughts. It's
Okay, we're going to close the poll in a few seconds to make sure you've answered.
All right, so 57% of the people said 104 is the ideal temperature. We got a couple at the 90 degrees, the 120 degrees, and some even said 135. So we got a pretty broad spectrum. So with that said, we'll get into the presentation. Hopefully we'll learn what that ideal temperature is. Hand washing temperature is important, but I think we all know that the temperatures that can kill germs are completely unsafe for hand washing. So what role does temperature play in hand washing? The proper temperature promotes the right activity, but it also helps support the soap's breakdown of the oils and bonds of those germs to the skin. So warm water helps soap break down the bonds of oils and allows the soap in the water to physically remove the bacteria and the germs off your body. As you can see on these charts, the higher the temperature, the better the breakdown is. But if you're getting to 140 degrees, obviously we understand that that is a secondary hazard. So 104 degrees, kind of right in the middle, is a good temperature. Ideal hand washing temperature is completely subjective. Human behavior is the goal. Water that's too cold, water that's too hot are going to have negative results. Rinsing thoroughly is the key. Water works as the physical cleanser and washes away the organisms and microbes off the hands. Public hand washing temperatures. A couple of different organizations out there to kind of tell the story a little bit. So the National Restaurant Association recommends hand washing should be at least 100 degrees. International Food Safety Quality, temperature range 95 to 113. Here in the US, most of us have to deal with codes that dictate what those temperatures are. And what do the codes say these temperatures are? So the main thing is to prevent scalding. 3rd degree burns if exposed to 150 degrees for 2 seconds. 6 seconds of 140 degrees will give you the 3rd degree burns. Understanding the scald is one of the key goals of ASSE, and they state any temperature above 120 at the point of use is a hazard. Summary of the key points around hand washing is it can save lives. The most important thing to do is increase the duration of scrubbing with soap and rinsing thoroughly. People wash their hands more if the sink and soap are visible, accessible, and sanitary. Using soap is important and is proven to be more effective with warm water. So we mentioned temperature subjective. There's a couple of different organizations out there that give suggestions, but what do the codes say? So we'll talk UPC, Uniform Plumbing Code, developed by IAPMO, to govern the installation and inspection of plumbing systems. IPC, International Plumbing Code, sets the minimum requirement for plumbing systems. National Electric Code, anytime you're installing a piece of electrical equipment or electrical wiring, you got to make sure that it's safe. International Energy Conservation Code, relatively new body, but it establishes the minimum design and construction requirements for energy efficiency. And then another one to pay attention to is American National Standard Institute. I don't think we'll get too much into that today, but it doesn't play a huge role in hand washing, but it is another code out there when developing water systems. So you want to develop a project. Where are you and what codes do you have to abide by? One of the first and simple questions that you got to answer, but may not be that simple. Depends on where you are, depends on where the facility is going to be, depends on what city, what municipality, what jurisdiction. So just make sure you know the codes that you got to comply to. What are all these codes doing? If you really broke them down into 2 bullet points after you read them all, which I haven't done, but if you go through them all, it comes down to 2 things: efficiency and safety. Whether that's water efficiency, energy, safe, reliable performance, user hygiene and safety, and mitigating the risk of design liabilities. Safety and efficiency all comes down to the right systems. And one part of that system is your fixtures. So 2018 IPC Chapter 4 Fixtures and Faucets and Fixture Fittings. What this does is it sets the minimum requirement for the number of fixtures based on the classification of the building and the number of fixtures per person. I will tell you, I'm kind of new to this section of the code, but it was kind of alarming when I saw how low these numbers are. So if you took a theater or a nightclub, a place of assembly, you're looking at 1 lavatory per 1 per 200, 1 per 75 people. That's not very many. Businesses and educations, 1 per 40, 1 per 50. As you can see, there's a pretty wide spectrum of number of fixtures per person. The one thing I am happy to say is, throughout my experience, I don't think I've ever seen a building with the minimum being the standard. Most of the time you're out and about, you see this number is not even a consideration. So that's a good thing. Now let's get back to temperatures. Code updates are always changing. You may get the trade publications, and there's always talks about different codes coming out or different changes to the codes. But UPC 2018 407.3 talks about the temperatures, the maximum temperature, and the temperature means a temperature regulation. They say that the public hand washing shall be a maximum of 120 degrees. And that temperature must be regulated by an ASSE 1070 rated mixing valve. A couple slides ago, we talked about ASSE mentioning anything above 120 degrees is a potential hazard. Therefore, they came out with the appendix, which dropped the maximum temperature down to 110 degrees. That temperature still had to be regulated through the mixing valve. 2015 IPC, they define tempered water as a requirement. The tempered water still had to be regulated through an ASSE 1070 rated mixing valve, and tempered water is defined as having a range between 85 and 110. So if you look at these 2 code bodies, which cover up 90% of the US, you get one commonality, is that the temperature has to be regulated through the ASSE 1070 rated mixing valve for public hand washing. And the maximum temperature is 110 degrees, but it may have a range between 85 and 110 depending on the code. So if we took a step back to the ideal temperature, I think the proper answer out of those options would be the 104 degrees. You're closer to the 110, above 90, you're below the 120, and it's really comfortable in promoting the right habits. So we know why we're washing our hands, we know how to regulate the temperature and what temperature, so how do we deliver it? So the International Code, IECC, they're really trying to promote efficiency with mechanical lighting and power systems. Again, relatively new body that's embracing conservation, new technology, correlation of different code bodies, and they're really trying to have an open and honest development system that's going to go through a 3-year cycle. So the way I look at it is they're just trying to put practical sense to all the different codes out there with some efficiency in mind. In the section 404, service water heating, supply piping, and it's this first section, it's nothing too crazy. General plumbing. How much water flow can I put through a specific pipe size? Again, just the charts there, nothing too crazy. What's interesting is when we get to the 404.5.2, the maximum allowable pipe volume method. Now, what this defines is the maximum amount of water that could be between your heated water supply and the termination of your fixture. Heated water supply could be a water heater, a circulation system, or a heat trace maintenance system. So that's, if there's any area for confusion in the code, it's going to be what's considered a heated supply. But for a public lavatory, that supply volume cannot exceed 2 ounces of water for a public hand washing facility. 2 ounces of water between your heated source and the termination of your fixture. All other plumbing fixtures can be up to a half gallon. So we talked why we're doing it, we talked the temperatures, we talked the temperature regulation, now we're talking distribution. How close does that hot water have to be to my fixtures? And for public lavatories, 2 ounces. 2 ounces, we all know you can calculate the volume based on the pipe size and the diameter, but they simplified it by putting out this chart based on pipe size, how many feet. So if you're doing public lavatories and you're using 1/2-inch piping, you have to be within 2 feet of your heated supply, 3/8, 3 feet. So it's kind of creating some waves in the industry. Make sure to understand whether or not you have to comply. While this is a national code, some states are absolutely 100% mandating it, some are not. So just make sure you understand your adoption policy for the jurisdiction that you're working in. So you get the codes, and then you get some regulating agencies that are really talking hand washing guidelines. So on average, how many times do you think people touch their face in an hour? Real simple question. I'm sitting here and, given this presentation, I've probably done it a bunch of times already. It's just something that we do without even thinking about it.
Okay, make sure you take a second to answer the second poll. It's going to close in a moment.
Again, 54% of the audience is, pretty much on target. We got 20, got some 30, 12, some 5. So it's pretty interesting. But there was a study done not that long ago, and it took a lecture, and they had a bunch of students in a lecture, and they videotaped them, and then they counted how many times they touched their face. And on average, 23 times across the hour. The more alarming, fact of this is that over half of those touches were to the transfer zones, which are going to be your eyes, your nose, and your mouth. The areas of the body where it's the easiest to transmit a disease or bacteria or germ. So I think we could all agree that over the past couple of months, we've been paying attention, a lot more attention to what we're touching than what we're doing with our hands. So kind of just a fun little fact there. Hand washing is important, but there's always alternatives. Hand sanitizers, they come in very handy, but they have limitations, whether it's supply and demand or the effectiveness. We know the hand sanitizer is based on the alcohol content, and it may not always be as effective. Gloves, while they have the right intention and if used properly, it can be extremely effective. The challenge is using them properly is generally not the case. World Health Organization, global programs and education, they're out there all day, every day, talking hand hygiene and the quality of care and patient safety in health systems. So if you're working on a health building, you got questions, World Health Organization is your source. CDC, guidelines and education. If you go to the CDC website and you type in hand washing in their search bar, you're going to get almost 3,000 different results of hand washing facts and articles. The 4 main topics: general public, healthcare facilities, commercial settings, and animal contact exhibits. So great resource for you. How many times do healthcare providers wash their hands in a 12-hour shift?
Okay, please take a second to answer this third poll.
We got a pretty smart audience here. So 41% stated 100, which is going to be the possibility. But CDC, hand hygiene for surgery, talks about the proper way to wash and your hands and your forearms and how it slows the spread of growth. But a healthcare provider might need to clean their hands as many times as 100 times in a 12-hour shift. We figure every patient, every activity, 2 to 4 times for every activity is what they really should be doing. So goes to show why these proper facilities are required. CDC again talking about food workers, and the one thing that the studies and their knowledge has shown is restaurants with more than the minimum required of hand sinks increase the use of those facilities. So get as many hand sinks as you can, make them accessible, make them clean, make them properly operating, and they will be used more effectively. So open concept kitchens are becoming more and more. Put those hand sinks out there. People like to see people washing their hands. ASHRAE, I'm going to kind of skip over this a little bit just for the sake of time, but ASHRAE Guideline 12 talks about Legionella and building water, risk management for building water systems, how healthcare facilities need a continual risk assessment to identify waterborne pathogens. Molly Scanlon here, she talks about how Legionella and waterborne pathogens can enter a water supply system from the very first scratch of the ground on a new construction project. From the rainwater to, the second you're breaking ground, the second you put a pipe on the ground, you're opening up the possibilities for cross-contamination in waterborne pathogens. So always make sure to have your safety at the top of the list for priorities. OSHA's out there. Everybody thinks OSHA's the bad guy. They want to give fines and they want to make money, but they're promoting the right habits of compliant, accessible, safe systems for the workers. They require restrooms, hot and cold water running, lukewarm water, adequate soap and water. So they're promoting all the proper systems. And to my point, they are trying to make some money, but they're trying to really force the compliance. But over the past couple of years, their fines have gone up significantly. And the number one violation is a willful violation. You know you have to comply and you're just ignoring it. Those fines could be all the way up to $135,000. So EPA promoting efficiency, residential water heating is the second largest consumer of energy in a home. How do you be more efficient? They actually put residential tank water heaters through an efficiency improvement plan back in 2015. EPA on commercial buildings talking about water conservation. How do we use more water efficiently and effectively? So work with them to understand different ways to improve your systems. But at the end of the day, effective public hand washing is dependent upon effective service water heating. Compliant, efficient, safe, accessible, and consistent. So let's talk some water heating. So we talked all about temperatures, regulations, why and how. How do we create hot water? One we all know is a tank type water heater. They were tried, they're proven, they're effective, but they're not the most efficient, but they've come a long way over the years. Basically, you have a cylinder that's holding a stored amount of water, and we're maintaining that heat at a specific temperature. You get heat loss, heating and cooling, which is where you get your inefficiencies. Back in 2015, I mentioned that they went through a process to make them more efficient. So manufacturers had to make their water heaters more efficient. If you have a cylinder that is inefficient due to the lack of heat, how do you make it more efficient? Wrap more insulation around it, which created different problems from a physical perspective. There are the old energy factors and the new energy factors. If you look at the above 55 gallons, they had to go from a 0.86 to a 1.97. That category water heaters could not meet that standard, so a couple size tank water heaters went out of production. So utilize the tanks when appropriate, but maybe there's a different option for you. One of those options may be a boiler, residential boiler or commercial boilers. Indirect heating is very effective if done properly. It can do multiple stations. It can do HVAC, it can do domestic, it can do process. You can get a lot of power and a lot of heat out of a boiler. The problem is that whole 80-20 rule. Generally, I've seen many times that they're oversized or not set up properly, so they're inefficient. With the progression of technology and BMS and system integration, we also got to make sure that the trades are 100% up to speed and the drawings and the specifications are done properly to make sure that the system is effective. Geothermal can be extremely efficient. The challenge is ensuring the site can accept the geothermal system. They can be expensive, but when done properly and in the right environment, they can be extremely efficient. Same thing goes with solar. PV or thermal, utilize the source that's shining down on us whenever we can. That goes into the requirement of a backup system, ensuring that you are able to support your systems even when the sun's not shining. So you use the renewables when feasible. Tankless, you're going to get two resources, gas or electric. You're going to get different construction types by different manufacturer and different resource. Whether you're using a heating element on the electric or a heat exchanger and a burner on the gas, the main function of a tankless water heater is to activate when the water flow is running, heats the water while that water flow is running. Once the water flow stops, power consumption stops. So a little bit more of an opportunity to be extremely efficient. How do we deliver hot water? Hot water delivery A, we're talking your central system, whether that's going to be a tank, a tankless, or a boiler. But generally they're running 24/7. You have opportunities for risk of bacteria and scalding if it's set too low or too high. Generally you're going to have a storage capacity. And again, the main benefit to a central system is you can do multiple applications with one system, but an extensive piping network and system integration. You could go with a secondary delivery option of utilizing tankless or specific equipment that is precise outlet temperatures, no storage, saving energy, fast and endless performance. Point of use capacity is generally one station. Everything we do in life, there's a trade-off. So with the boilers or the central systems, you get multiple. Utilizing tankless, you're going to be 1-to-1 ratio, or maybe 1-to-5, 6, depending on the application. One water line, no venting. So you got your opportunities to be LEED, net zero, carbon reduction. There's a lot of benefits when looking at your different scenarios. To put a graphical play on it, you get your on-demand distributed point of use on your left and your central traditional system on your right. While they can both be effective, they have different pros and cons. So understanding the technology and the systems and how to utilize them along with the application gives you the opportunity to promote and design the best system you can. So tankless electric, what are some of the benefits compared to all the others? Kind of a little redundant here. So tankless electric heats water on demand, no venting, compact size for easy and simplified installation and systems, wall mounted, and they can provide a 20-year lifespan due to the limited wear and tear from the limited use. All the others, you're going to have venting, more complex systems, longer pipe runs, less efficient, but understanding the project and the scope of it is the key to making the right system. And that's the goal at the end of the day. Know your goal, know the challenges, know the codes, develop a good system with a balance of performance and energy and efficiency, and utilize all of them if you have to. If you want to use a boiler or geothermal for your HVAC and then tankless for your water heating or renewables, you tie it all in. It may be a little complex, but if efficiency is your goal, utilize them all the most effectively. And that kind of ties into your building the project, and you're going over the scope, you're going over the consumption and efficiency, reliability, and codes. That all comes in before your cost of the system, comes into play. Not even the cost of the system, but the products, the installation, the maintenance, the ownership, that all comes into play too. And there's a lot of different products, a lot of different ways to complete your goal. But let's talk tankless and how that helps. Design benefits: promoting sustainability, healthy, comfortable performance while conserving energy, water, lower operating cost, and they are 99% energy efficient, or 99% efficient certified by AHRI. So if you're going for LEED, there's opportunity to gain some points. Water heat is heated on demand, and power is only drawn when needed. No standby heat loss, easy installations, no venting, improved hot water delivery, and reduction of the need of recirculation systems. So everything we talked about before, from your temperatures to your regulations to the IEC code, where you got to be within 2 ounces, utilizing the right equipment to meet these codes allows you to develop the right system. Attributes: this is one thing that a lot of people don't understand about tankless electric. Your performance spectrum can go anywhere from 0.2 gallons per minute for low flow hand washing all the way up to 40 gallons per minute for, let's say, tepid water or process heating. Anywhere from 1 kW to 150 kW. Pretty much any voltage option that you need, from 120 volts to 600 volts, both single and 3-phase. Temperature range hits the spectrum, and there's a couple different manufacturers out there that have different ranges, but for the most part, you're looking 60 to 180 degrees. And most manufacturers also provide, custom support, whether you're looking for a really one-off custom application, you're trying to solve problems, or you're just looking for a little bit of hand-holding as you're starting to learn the technology. Reach out and we'll help you. A couple of the misunderstandings and realities. I've been doing this for a while. I just hit my 20th year, and we hear all the time misconceptions of what people don't understand. So curious what you think the greatest benefit of using tankless electric water heating is.
Again, please take a second to complete this poll. We'll give everyone a few more seconds to make their choice.
So we have people touching a little bit on everyone, and I don't think there's really a right or wrong answer here. The majority of people went with saves energy, which is definitely one of the better benefits, but it depends on the goal that you're trying to achieve. So no wrong answer there. So one of the misunderstandings versus reality. Okay, a lot of times we hear you don't save money with tankless. There's a huge potential to save money utilizing electric tankless. When we talk hot water distribution, we got recirculation versus point of use. This chart represents a recirculation loop of a 500-foot loop, circulating 140-degree water through 1.5-inch piping with 1 inch of insulation, paying 14 cents a kilowatt hour. If you are able to remove this recirculation system and use different technology at the point of use, you have the potential to recoup almost $33,000 in heat loss. That's $33,000 of just heat loss. That's not pumping, that's not maintaining, that's not creating, that's just the heat loss. So understanding the application allows you to be more efficient. We always hear that they draw more power. It's not a matter of consumption, it's a matter of time. It takes the same amount of power to heat water no matter how you do it, it's only the time. So tanks do it by hour, tankless do it by minute. So if you're going to run a marathon, it's 26 miles. Whether you walk it or crawl it, doesn't matter. You're going 26 miles. How long does it take? So tankless electric consume more power at the time of use, but the times of non-use is where the balance is and where your efficiency gains are. So the challenge can be getting the right infrastructure. So always think tankless early in the equation to make sure you can support the infrastructure. Per NEC 422.10.11, tankless water heaters are valued at 100% of their rating. Therefore, you do not need to oversize the circuitry and breakers to 125%. Obviously, check your local codes. So at the end of the day, what's the biggest benefit? It depends on you. It depends on the project. It depends on what your goal is. But you have the opportunities to save space, save energy, save water, save money, all while promoting efficient, compliant, accessible, safe, consistent hand washing. Reduction of your carbon footprint, no venting, no greenhouse. If that's your goal, you got the opportunities to leverage the technology. So effective service water heating supports effective hand washing, mitigates environmental impacts, enables improved healthy habits for everyone. This was a project that we talked about earlier where we did the pro tour. First net zero school in Massachusetts, the largest net zero building in the state of Massachusetts. And it truly was a beautiful project because early on I mentioned utilize everything. And they pretty much did. They had geothermal for their HVAC, they had solar, they had radiant panels, and they used electric tankless water heater throughout their facility for hand washing, janitorial requirements, and tepid water safety systems. So electric kitchens, I mean, it truly was extremely well done. Supports the environment, it supports the neighborhood, achieved the right efficiency goals, promoted the right habits. And at the same time, it's a beautiful facility. If you're ever interested, we have a video that we all work together on to develop. You can kind of take a tour, you get interviews. Feel free to check that out on our website or YouTube, and maybe it's even up on Nessie. I'm not too sure there. So again, I went through this kind of quick to make sure we could touch on everything, but we talked codes, health organizations. Why do we wash our hands? How do we wash our hands? What temperatures? How do we regulate the temperatures? Difference between water heating technologies and water heating distribution, tankless electric benefits. At the end of the day, it's completely up to you how or why or how you're doing a project, but just make sure you're truly utilizing all the technologies available to do the best that you can. So that's the end of the presentation, and I will open up some Q&A here. It only looks like we have a few. Are employee-only restrooms considered public? You know, that's when I was going over the public and private, I mentioned there's confusion in regards to how they're classified. And that is an area that a little bit of a gray area. Employee-only restrooms, from what I understand, if it is, let's say, a CEO office and it is intended for only his use, then yes, it would be public. But if it's a general use office, a cubicle for visitors, then it would be private. So that may not be exactly the correct answer, but that's how I would interpret it. But there are gray areas with every code out there. Can you give some examples of different hot water heating systems that would comply with the limit of 2 to 3 feet from the heating source? So for the IEC code, it states that you have to be within 2 fluid ounces from your heated source to the termination of the fixture. The heated source is generally going to be a water heater, a recirculation loop, or a heat trace temperature maintenance system. So if you use a tankless water heater underneath the fixture, you have the ability to be right at that point. You could be within 6 inches. If you're using a recirculation system, what used to be a 10-foot or 50-foot distance between your loop and the branch to the fixture, now that loop has to be so much longer to get as close as possible. We showed the chart that represents the heat loss. So that loop was 500 feet. If you had to increase your distance, now you're at 700 feet. What's going to happen? You're going to lose more heat. You're going to be less efficient. So using the technologies like a tankless water heater or even small water heaters closer to the fixture allows you to be compliant and more efficient. What are the limits of tankless? There are definitely some limitations, and a lot of it is going to be project specific. So the flow rate and the temperatures are the two things to consider, but generally the limits. So what limits the use of tankless is generally the electrical infrastructure, and that is normally due to people not considering tankless early on in the design equation. So for a hand washing station in New England, half-gallon per minute hand washing, you're looking at 30 amp circuit. If you did 100 of them, that's 100 30 amp circuits. That may not jive for every project, and if it came in after the fact, they may not have the facility or the support to do it. Maybe the sheetrock was up. But if you considered that early on in the equation, you can look at option A, which is going to be your boiler and recirculation, versus option B, electric tankless. 100 circuits versus a million BTU boiler, all the venting, all the pumping, all the maintenance. There's trade-offs. So just if you're going to consider it, think about it early. But the technology has expanded so much over the past 10 to 15 years that a lot of those limitations have we've surpassed the limitations. Have you ever encountered difficulty in meeting HERS rating requirements in multifamily housing? To be honest with you, I don't know the answer to that, but I can look into it and find out. Does the cost savings math still work with large commercial tariffs? It can. I mean, there's so many different factors in regards to the overall cost of the product that you gotta look into the numbers, but the efficiency is there with tankless electric, 99%. That doesn't change. Cost of the products of everything that we're doing, and the tariffs, there's a lot going on. So look at the math, but the efficiency at 99%, that's not going to change. When we were kids, we had these big hand washing stations that 5 or 6 kids could all stand at. Are those as hygienic as single person labs? I guess the question there is hygienic. I mean, washing your hands is about using warm water with soap, scrubbing properly, and rinsing thoroughly. It's all about promoting the right habit. So maybe if you get a group of elementary school kids around one of those big things, they're gonna have fun and they're gonna make a game out of it. So maybe they'd be more effective at washing their hands than just having a single station. From a cleanliness, that's up to the facilities and the janitorial to clean it, but effective hand washing is about the habits of the user physically doing it properly. Are there any specific considerations when dealing with preschool students? To be honest with you, I haven't seen anything. I think that would be more of a local jurisdiction, your state and your city that may have specific requirements for specific ages. The school that we just mentioned was elementary, middle, and they complied with the IPC codes to the 110, 85 to 110 range. So I don't know if there's any specific requirements for preschool. How often do electric tankless need maintenance or replacement? Obviously, the wear and tear and the use, the water quality is all going to come into play. But one thing I will say is they are generally maintenance free. Good maintenance habits of a facility are what we would default to. If you have extremely hard water, certain areas of the country like New Mexico have extremely hard water, that might be a little bit different. But speaking Emacs, per our warranty and instructions, there is no maintenance required. Can I talk more about electric tankless power consumption? So maybe what we could do is at the end of this, we'll send you a document that shows how to calculate the power. But it's the laws of physics to heat 1 degree, 1 pound of water 1 degree in 1 minute. But depending on the application, as I mentioned earlier, in New England, to do a ½ gallon per minute hand washing station, you could be up to 30 amps depending on the power supply. Also remember the voltage that you supply to the equipment, the lower your amperage is going to be. So you always got to calculate your kW. So hand washing, bare minimum with electric tankless, 3.5 kW. Kitchen sinks, you may be up to 12 to 14 kW. But think about the elimination of the recirculation systems and all your efficiency gains. What are your thoughts on supplying electric tankless water heaters with hot domestic water to eliminate the waste of water? So that's using multiple systems together. So let's say you had a system and you're retrofitting it and it has an existing boiler and everything's fine. Do I have to make any changes? Let's say you had to comply with that new IEC code where you got to be within 2 feet. You can use the right electric tankless to supplement that system. You can put it on the hot water line, provide instant hot water for the use. When your primary source reaches the tankless, it's going to sense that temperature and adjust and modulate accordingly. So you can use tankless and tanks and central systems all together to create an effective system. We're discussing hand washing, but what about the residential showers? Are larger capacity tankless electrics that can handle 5 to 10 minute shower volumes? So as I mentioned, tankless electric, they can go anywhere from 0.2 gallons per minute all the way up to 40 gallons per minute. Talking residential, generally you're around the 2 gallon per minute mark. There's a good selection of options available in the market to support that. Residentially, there are limits to the tankless, and I apologize to the other person earlier that asked about limits. Residentially, there could be some limits when you start talking the shower systems with multiple shower heads, where you're talking 8, 10, 12 gallons per minute. Tankless may not be your best bet there. Or drop-in tubs when you get a tub faucet that can do 15 gallons per minute. That may not be a very viable option. But reach out to us, let us know your thoughts and questions, and we can help you walk through that scenario. How much of an impact does a large number of on-demand heaters like the 150 play on the electrical loads needs for the building? How many can you run at a time? There's diversity in plumbing, but there's no diversity in electricity. So if you're installing one, you got to make sure it can operate. That's my answer to that question. Maybe there's different distribution methods and different panels, and maybe there's something a little bit above my head on the electrical side, but general rule of thumb, if you're hooking it up, you got to be able to run it. Can you address multifamily on-demand electric water heating advantages, disadvantages, energy codes, how the HERS rating? Again, I don't know much about the HERS rating, so I'll pass on that one, but we will look into that and get back to you. If non-use, when saving the most, saving must be quite different in high use 24/7 facility versus the 9 to 5. So thinking about the recirculation chart with the heat loss calculations, I said when I was looking at it, I said this may be the right system. Let's say you're looking at a manufacturing facility, and you got 500 people throughout the building, and they're washing their hands and showering and doing everything, and that central system is pumping 24/7. Maybe that is the right system to be the most effective to deliver the right performance when needed. The less frequent that system is used provides the most opportunity to gain efficiencies. So understanding the demand, understand your piping allows you to be effective. So, but let's say you had that 500-foot recirculation loop and it was really the right system for that project, but somebody wanted to do an addition and add an office wing. and at the end of that office, they were going to put, a men's and a women's room. Would it make sense to tap onto that piping network and run the loop another 400 feet down and back, or use two tankless for the men's and women's room? Understand the challenge, technologies, do the right thing. Is there any special load diversity allowed for series of tankless electric water heaters to limit the main panel? I don't know. I'm sure there is, but again, that kind of exceeds my expertise. But when you start getting into SCCR ratings and diversity factors of electricity, which I don't believe there are any, I would truly default to your electric code and your city codes and do it by the standard. And I think that might have been all the questions there. One more. Are there any significant differences with your tankless water heaters and those manufactured by Stiebel, Eltron, or other manufacturers? There's a couple of different manufacturers. There's about a handful of them out there. Stiebel is a very notable manufacturer. They make a good product. So if you ask me, I would recommend 4 different brands. And each of those manufacturers, from a conceptual standpoint, are doing exactly the same thing. They turn on when water flow is running, they heat water with a method of transferring heat, and they have a control logic, which is modulating the power. Each one's going to be a little bit different in how they do it, but just make sure you're getting a product that fits the application. Understanding the application, picking the right unit, and providing the right installation is the key to making sure an electric tankless, no matter what brand, works properly. And I think that's it.
Thanks so much. And thanks everyone for joining us. To Chris and Selena and everyone at Emacs, we'll be sending out follow-up email to everyone who attended to ask for feedback and ideas about how we can continue to be a resource for you remotely. Please don't be shy about telling us what you think, and be well, and keep an eye out for more opportunities to connect with and learn from each other through NESI in the near future. Thanks again, everyone. Take care.